we're asked to graph the y position of an object that starts in the circle at the pi/2 position and moves around the circle in 8 seconds. The circle has a radius of 4. So when we plot y versus x, we start at a y position of 4 units above the equilibrium or middle position, the center of the circle. So that y altitude is 4, and then of course decreases down to -4 and then back up to 4, and that completes one cycle corresponding to one trip around the circle, and that occurs in 8 seconds. We next wish to see what the function is. Y equals a sine of what, or what kind of a function do we have? How would we label, how would we characterize the function of this blue curve? We could begin with what we know about the period. The period is 8 seconds. We could say if we do the sine of 2 pi over 8t, then we know that the period is 8 seconds because we know that the period is going to be divided into the 2 pi. That's so that, again, as t goes from 0 to 8, 2 pi over 8t will go from 0 to 2 pi. You recall that from last time. And that gives us a graph that looks like this, which is a good start. It has the right period, but we need to shift the graph over so that its peak occurs at the initial time at t equals 0. And we also need to stretch it out so that it has an amplitude of 4 rather than an amplitude of 1. Okay, in order to do that, we say, well, here's our reasoning. Okay, our period is 8 seconds. Is y equals sine of 2 pi over 8t going to give the result we're after? No, it's a start, but it's got the wrong position at the start. Okay, y is 0 at the start where we need a y of 4. And it's got the wrong amplitude, so we want to get the right amplitude. It does have the right period. Now, in order to stretch this thing out vertically so that it goes 4 units instead of 1 unit from the equilibrium position, we just multiply our sine by 4. So we multiply all our y's by 4, accomplishing essentially vertical stretching of the graph. And that'll give us the amplitude that we need. So multiply all our y's by 4 by putting a 4 here. The fact that the position should be, or the angular position that is, the position on the circle should be pi over 2 when t equals 0, says that maybe we just need to add pi over 2 here. Because then when t equals 0, we'll be taking the sine of pi over 2, which is 1, and that'll give us our y equals 4. So again, corresponding to our initial condition that we are at the pi over 2 angular position when we start, we throw a pi over 2 in here. We add the pi over 2 so that when t equals 0, we are at the pi over 2 position. And that's generally what we do. In order to do another problem that's posed, starting at 3 pi over 2 and moving around the circle in 3 seconds, what are we going to do in this case? Well, it's the same circle, it has the same amplitude. The 3-second period is going to go here so that, again, 2 pi over 3t changes by 2 pi as t goes from 0 to 3. And the starting angle, t equals 0, is 3 pi over 2. And we just add the 3 pi over 2. Note that this has the effect of shifting the graph from this kind of a phase where the peak occurs here to the left so that the peak occurs here. So when we add to the angle, to the initial angle, that moves us further around the circle and actually shifts the graph to the left.